to my channel. If you're new here, don't forget to hit the subscribe button and ring the notification bell to stay updated with all my latest content. This is my new channel where I will post about AI, machine learning, Python and other cool stuff. Today we're diving into some exciting tech, specifically how to use RAG Retrieval Augmented Generation for information retrieval from the PDF or other sources. So, the first question will be, what is RAG? Here is the explanation in simple words.
Imagine you have a huge library full of books, and you want to find the answer to a question like, why is the sky blue? But instead of reading every book yourself, you have a special robot friend. 1. Ask your question. You ask your robot friend the question, why is the sky blue? 2. Finding the right books. The robot doesn't know the answer right away, so it zooms around the library and picks the books that might have the answer. 3. Reading and summarizing. The robot reads the important parts of those books and puts the pieces together. 4. Giving you the answer. Finally, the robot tells you the answer in a way that you can understand. So, the RAG technique is like having a super smart robot friend who helps you find answers by looking through a lot of information and telling you the best parts.
I hope it is clear to you now, so let's start with our RAG application. We'll work with powerful tools to load, process and retrieve information from a PDF document. In my case, I am using Harry Potter 2. I'll walk you through each step. We will use LangChain and Google's Gemini model to process and query text from the PDF document. We'll go step by step, so by the end of this video, you'll know how to set up everything and make use of these tools effectively. Step 1. Mount Google Drive first. Let's connect Google Drive to our Colab environment. This allows us to access the PDF file we'll work with. Here's how you do it from google.colab import drive. This command mounts your Google Drive, giving the Colab environment access to your files. After running it, you'll be prompted to authenticate and allow access. Now, we will check where our PDF is located. Go to Drive, then My Drive. Here we can see our PDF titled Harry Potter 2. We will now move to step 2, which is to install the necessary libraries. We need to install some key libraries that will help us with document processing and retrieval. The libraries include LangChain and additional components like LangChain, Google Gen AI, ChromaDB and PyPDF. Here's the command to install them. Pip install LangChain Google Gen AI, pip install LangChain Community, pip install LangChain Text Splitters, pip install ChromaDB, and pip install PyPDF. Running these commands installs all the necessary packages. LangChain Google Gen AI connects us to Google's Gemini model. LangChain Community and LangChain Text Splitters help us manage and process text data. ChromaDB is used for storing and querying text embeddings, and PyPDF allows us to handle PDF files. We have to import the following libraries. Now we will move to step 3, load the PDF document. Now that our environment is set up, let's load the PDF document. We'll use the PyPDF loader from LangChain's community package to do this. From LangChain community.document loaders, import PyPDF loader. Load a PyPDF loader and enter the path of your PDF. Data loader.load. In this step, we're loading the entire PDF document into our environment. the PyPDF loader reads the file and stores its contents as a single document in the data variable. This will allow us to work with the full text of the document later on. Step 4. Split the document into chunks. To make the document more manageable, we'll split it into smaller chunks using the recursive character text splitter. From LangChain.text splitter import recursive character text splitter. Text splitter equals recursive character text splitter. Chunk size will be 1000, chunk overlap will be 50. Docs equals text splitter.split documents and pass the data. Here we're using the recursive character text splitter to break the document into chunks of 1000 characters with a 50 character overlap between chunks. This makes it easier to manage and process the document, especially when querying specific parts of it later. Check the length of the docs now. Step 5. Setting up embeddings and creating a vector store with Google Gemini. Now it's time to set up the embeddings using Google's Gemini model and create a vector store using Chroma. These embeddings will help us later when we query the document. Here's how you can do it. From LangChain Google Gen AI we have to import Google Generative AI embeddings. Import Chroma. Store your Google API key in Google API key variable. In this step we're doing two things. First, we're using Google's Gemini model to create embeddings from our document chunks. These embeddings convert the text into numerical vectors. Next, we store these vectors in a vector store using Chroma. This makes our text searchable and ready for information retrieval. Step 6. Retrieve information using LangChain and Gemini. Now that everything is set up, we can retrieve information from our document. We'll start by setting up a retriever. In this code, we're creating a retriever to search through our vector store. The search type is set to similarity, meaning the retriever will look for document chunks that are most similar to the query we provide. The K parameter is particularly important here. It determines the number of top documents the retriever should return. In this case we've set K to 5, so the retriever will give us the top 5 most relevant document chunks that match our query. Next, we'll set up a chain that uses LangChain and Google's Gemini model to generate a concise answer based on these retrieved documents. We need to import some libraries like Chat Google Generative AI, Create Retrieval Chain, Create Stuff Documents Chain, Chat Prompt Template to create the question answering chain. We create an instance of Chat Google Generative AI, configuring it to use the Gemini 1.5 Pro model. We set the temperature parameter to 0, which means the output will be more deterministic and less creative, providing more consistent responses. The max tokens parameter is set to 500, limiting the length of the generated response to 500 tokens. Here we will provide system prompt, which instructs the model to use only the retrieved documents to answer the question. This ensures that the answer is directly based on the content we've pulled from the document. You can change the system prompt according to your requirement. The model is instructed to respond with, "The information is not available in the documents provided if it cannot find the answer within the provided context." It is also directed to keep the answers concise, using a maximum of 3 sentences. The prompt variable is created using chat prompt template from messages. This function constructs the final prompt template, combining the system message that is, instructions, with the human message that is, the user's question. The placeholders, context and input are used to insert the retrieved documents and the user's question, respectively. The question-answer chain variable is created using the Create Stuff Documents chain function. This chain combines the AI model LM with the custom prompt that is prompt to generate a response based solely on the retrieved documents. The RAG chain is constructed using Create Retrieval Chain, which links the retriever which is responsible for fetching relevant documents with the question-answer chain. This chain effectively retrieves the necessary documents and then processes them to generate a concise answer to the user's question. The RAG chain is invoked with the input question, "What does Dobby the house elf do with pudding?" This triggers the chain to retrieve the relevant context and generate an answer based on the provided documents. Finally, the model's response is printed to the console using print response answer. This will display the concise answer generated by the AI model, following the constraints defined in the system prompt. Next, we will ask, "Who was Sirius Black?" It should answer, "The information is not available in the provided document." because we know that Sirius Black was not introduced in the second part of the Harry Potter. To confirm that, I will show you by searching Sirius Black in the PDF document. Now we will ask next question, what was the name of Dumbledore's bird? Next we will ask another question, how did Fawkes die? Now we know that Fawkes is a phoenix and it cannot die, so the answer should not be fabricated. And that's it. You've just seen how we can use LangChain and Google's Gemini model to process and query text from a PDF document. This setup is incredibly powerful for tasks like document analysis or information retrieval, and it's all done in a few simple steps. We've manually checked the answers to each question using the PDF document. In the next video, I'll share some techniques we use to evaluate the performance of large language models LLMs, so stay tuned. If you found this video helpful, make sure to hit the like button, subscribe to the channel, and share it with others. And don't forget to turn on notifications so you never miss an update. Also, I'll provide a link to my collab notebook in the description, so you can follow along and try it out for yourself. You can use this approach with any PDF document. Thanks for watching, and I'll see you in the next video.